I want you guys to understand one SOHCAHTOA. That's one like a acronym to memorize this trigonometry. And the other thing I need is a right triangle. So let me draw a right triangle here. So this is a right triangle. So I'm going to say this is a right triangle 90-degree angle. I'm going to name this triangle as a triangle ABC. This is a right triangle. And this is right triangle, and angle B is 90 degree. And I'm going to mark angle C is a theta. Angle theta is C. Okay. So to solve these, sine square theta plus cosine theta square theta equals 1, well, we need to start with a right triangle. So if we use a SOHCAHTOA for this right triangle, if you look for a theta, see this theta is the angle, this side is opposite, and this is hypotenuse. And one more thing we need to remember is for the Pythagorean theorem, it also does a square plus b square equals c square. Square of the sum of the square of the two legs is equals to the square of its hypotenuse. So what is happening here? If I use this, so let's say this leg is A and this leg is B. Doesn't matter, it goes here or that. This legs can be straight, and this is C. So what we do is I'm gonna use sine trigonometry SOHCAHTOA. So this is for sine, opposite over hypotenuse. If you take this is sine theta, then it's gonna be opposite over hypotenuse. So opposite is leg A and hypotenuse is C. So sine theta is sine angle theta equals opposite over hypotenuse. So the opposite of angle theta is opposite is A over hypotenuse is this is C. So opposite over hypotenuse is A over H. That's for sine theta. Okay. If to do same way for cosine theta, which is cosine theta is this is cosine theta. So cosine is adjacent over hypotenuse. So theta, this is the angle adjacent, the side adjacent to this angle theta is side B. So cosine theta equals adjacent over this is adjacent over this is hypotenuse. So I'm gonna write that down. Adjacent and this is hypotenuse, and this is opposite over here, and this is hypotenuse. And just write it down quickly. So for cosine theta equals adjacent over hypotenuse. So your adjacent is B over hypotenuse is C. So I think I put it here H. So this is C. Okay, this is hypotenuse is C. H is just for saying hypotenuse H. So here, if we do that, now I'm gonna plug this two thing here. I'm gonna plug this sine theta and cosine theta in the given equations of the left side. So sine square theta plus cosine square theta. Now plug this in. Sine square theta is A over C square plus cosine square theta. Cosine theta is B over C. So cosine square theta has to be B over C square. Let me rewrite it, make it better. So B over C square. Okay. So for further, then you can square the top and the bottom. That will be A square over C square plus B square over C square. I'm gonna write it up here so I don't have to lean it down. So A square over C square plus B square over C square. Since we have the same denominator, common denominator, we can write C square at the bottom. And both numerator comes together as a sum A square plus B square. So as always in Pythagorean theorem, sum of the square of the legs equals sum of the square of the leg equals the square of the hypotenuse, which is A square plus B square, also as a C square over C square. That gives you 1. That means it's been proved. So sine square theta plus cosine square theta, when you simplify it, you get equals 1. So therefore, sine square theta plus cosine square theta equals 1. Now,
put a box around it.
Okay, so sine square theta plus cosine square theta equals 1. That's